In 1977, NASA sent 2 golden records into space, aboard the Voyager 1 and 2 spacecraft. The Voyager probes have become 2 of the farthest-reaching objects ever launched by humanity. And the golden records, real functioning LPs, contain something utterly unique: audio and images from Earth. By 2030, both Voyager 1 and 2 will cease communications for good, and while they won't be able to beam information back to Earth, they're going to continue sailing through space at almost 60,000 kilometers per hour. The hopes are that one or even both of these records will be intercepted by another advanced civilization, revealing a treasure trove of information that will teach whoever finds them about our pale blue dot of a home, light years away. But in order for anyone or anything to see the images contained on the record, they'll have to decode this. And we're going to show you how. If extraterrestrials do find the golden records, the first thing they'll come across is its cover, which looks a lot like this. It contains a handful of unique symbols that properly explain how to play the messages sent from Earth. And at first glance, they're pretty complicated.
I tried to think, how would an alien look at this picture? And there are always 2 requirements. You wanted things to be as easy as possible to understand, as clear as possible. But you also wanted, in a limited number of pictures, to have as much information as possible in each picture. So those 2 requirements are kind of at odds.
That's John Lomberg, Carl Sagan's longtime friend and collaborator. John helped curate the contents of the golden record and designed the cover.
It's permeated the culture in a lot of different ways.
The largest of the designs on the cover is the pulsar map. It helps explain our location in the universe by triangulating Earth's distance from various neutron stars, collapsed stars that give off pulses of radiation, or pulsars. While this information doesn't help decode the record, it would give anyone who finds it a clue as to where it came from in the universe. Every other symbol on the cover, though, is there to explain how to properly play the record and decode the audio. Getting the songs and sounds to play are pretty straightforward. Figure out the correct rotation and speed, and they'll spin just like a normal record here on Earth. Granted, for an alien, figuring out how to work a record might be a challenge in itself.
That should be very easy for them to discover. But that's not all that's on the record, and understanding the rest of it is a little bit harder.
You might think that the images included on the Voyager spacecraft were printed out or included in some digital form, but the golden record isn't a digital disc. There are no JPEGs or TIFFs included on it. The Voyager's computer systems were only 69 kilobytes large, barely enough for one image, let alone 115.
And at that time, in 1977, there was no conventional technology for putting pictures on analog discs.
NASA had to be a lot craftier with the technology that they had available at the time, especially with the amount of data they were looking to send. And they managed to encode that image data within the audio waveforms themselves. But in order for us to find that data, we need to figure out the rest of the symbols on the cover of the record. Starting on the bottom right, we have a diagram depicting hydrogen, the most abundant gas in the universe. I spoke with Jacqueline Van Gorkum, a professor of astronomy at Columbia University. She explained to me that once in a blue moon, the electron in a hydrogen atom changes the direction of its spin.
And so this transition, this happens spontaneously once every 10 million years, emits a little bit of energy, so it emits at 21 centimeter wavelengths.
The hydrogen atom depicted on the cover of the record is undergoing that very unique change, called a hyperfine transition. And what it emits, the 21 centimeter line, is a very specific radio wavelength that astronomers use to map the galaxy, 1420 megahertz.
It's sort of mind-boggling.
NASA uses that 21 centimeter line as a constant for all the other symbols on the record. If you convert that 1420 megahertz signal into seconds, you get 7.042 times 10 to the negative 10 seconds, or 0.7 nanoseconds. And that one number helps us unlock the rest of the record's symbols. For instance, here's a side view of the record that depicts this binary number around its diameter. When converted to decimal and multiplied by our hydrogen line constant, we get 3,229 seconds, or roughly 53.82 minutes, the total runtime of the record from beginning to end. And on the top-down view, converting this binary number to decimal and multiplying by 0.7 nanoseconds, you get 3.59 seconds, the time it would take for one rotation of the record. So when we play the record that fast, we should hear these sounds. Greetings in 55 languages.
Hello from the children of planet Earth.
samples of music from around the world, sounds of Earth such as oceans, birds, thunder, and whales. And on the other side, this. It's that sound that contains all of the image data for the photos and drawings contained on the golden record. And using the process described in the last few symbols on the cover, we can render the images. This is where things get really interesting. The top right symbol shows how the waveform data should be broken up, with each section of the waveform taking 0.008 milliseconds to play. And according to the symbol below that, each of those sections of data completes one out of a total of 512 scan lines that make up a completed image.
To understand the rest of that diagram, you'd have to understand how an old-fashioned cathode ray tube television worked. And few enough people understood it at the time when they were still in use, and fewer understand it now.
And while I don't understand cathode ray tubes, I tried an alternate method. Using Audacity, a free audio program, I selected 0.008 milliseconds of audio data between each peak in the waveform, roughly corresponding to the area selected on the cover of the album. I exported that data into a CSV file. The data being exported is essentially just number values based on the volume of waveforms at different points along that 0.008 millisecond section. When you import the CSV into Excel, you can use conditional formatting to assign a different color value for different decibel levels. Lower decibel samples translate into lighter grays, and higher decibels into darker grays. And after doing this for 12 hours and 512 times, we got this. Now, a circle isn't the most exciting thing in the world, but it has a very important purpose. If we look at the last image on the record's cover, we'll see the calibration circle. It's a major waypoint. If aliens manage to decode a shape that matches this, then they'll know that they're onto something. There's no way we're going to do that for the remaining 114 images, but fortunately, we live in a world where code can help, and maybe aliens will too. We reached out to Manuel Ortoro's Kyoto, an anthropologist who wrote his own code in one night to make this process much, much faster.
Basically, the idea is take the thread of the numbers and fold them in a way you can convert the thread into a kind of surface. Yeah?
Manuel's code takes these 0.008 millisecond signals and folds them as they would appear in an old television set, rendering an image. He uploaded the code to GitHub for others to use, and Emily Malik Brown, a developer on our product team, helped get the code up and running on my computer. To our astonishment, the images appeared right before our eyes, proving that even 40 years later, and with completely different technology, the messages could still be properly decoded. So, with the help of an astronomer, an artist, a coder, an anthropologist, Microsoft Excel, and Python, we were able to decode the golden record. But let's not forget, we're not the intended audience for this. Is an extraterrestrial civilization really going to have a shot at this? For John, that's really besides the point.
Whatever happens to it in space, whatever its unknown destiny is, I think it represents a high watermark of our civilization when we dreamed the biggest dream, really. And I hope it will serve as an example and inspiration for people to keep dreaming.
Hey everyone, thanks for watching our video. Check out Vox.com's Golden Record video where they have a selection of the images and some of the audio and songs that played as well. And don't forget to subscribe to our Verge Science YouTube channel. Thanks.